This person was 1.5 over the mean. This person was 0.5 over the mean. This person was 0.5 under the mean, 1.5 under the mean, and 2.5 under the mean. So right here, what this is doing is taking into consideration how these people are different from the mean, or how they deviate from the mean. Okay, and that's what variability is, right? We know we're not average. None of us are average, and we know that. And so the statistics, what it's doing right here is it's taking into consideration how are each of these people different from the mean. Okay, now we have to square them. Okay, and why we have to square them is because if you add it up, this column right here, it will come to 0. It will add up to 0. And you can see there, each one of them negates each other, right? We have a 2.5 and we have a negative 2.5. We have a 1.5 and then we have a negative 1.5. We have a 0.5 and we have a negative 0.5. So we can't add that up right there. We can't sum those deviations. If we sum or add up those deviations, we're going to get 0. We have to square them. Okay, and so when we square them, it takes away the negative part. And what it's doing for us is just giving us an absolute deviation from the mean. Okay, it's giving us a real number that we can work with. Okay, so that's why we square our deviations from the mean. Okay, so what's happening here, right? Just to go back, I'm sorry, I know this is getting a little bit complex here, or too many scribbles. So what we're doing is we're taking that 2.5 and we're squaring it, and it gave us 6.5 or 6.25. Sorry about that. 1.5 squared, you'll get 2.25. 0.5 squared, you'll get 0.25. Okay, and then here's the fun part. One of the only things I ever remember from regular math is when you multiply a negative times a negative, it goes positive, right? So I punched it in there, I think. Oh no, right here. Negative 0.5 squared is still 0.25. It becomes positive. And that's why I say don't stress too much about the negatives. We're not going to completely discredit them. Okay, they're still important, but we don't have to worry about them too much. Okay, so I just went through there and squared all of those numbers. Okay, if your calculator does not have the square button, that's okay. You can do this. You can do negative 1.5. What did I hit? Not hit the negative? Oh, there, negative 1.5 times negative 1.5. Did it come out? Negative equals 2.25. Okay, so if you don't have the square button, you can just multiply it by itself. 1.5 times 1.5. Okay. Any questions over that part? No? Okay. Whatever calculator you're using, please practice on it and get familiar with it, because all calculators are different, okay? And so I just want you to become familiar with whatever you're doing. I'm not trying to insult your intelligence at all. I'm just want you to do that, okay? Play with it a little bit. Okay, well, I think maybe we can put him away real quick. All right, so is everyone okay with where we got these numbers from? Are there any questions about that?
Oh, I have one real quick. How did we get the 17.5?
Excellent question. Right here, we add all of these up. We add up, let's see, I'm going to take away some of this stuff. We add up the 6.25, 2.25, 0.25, 0.25, 2.25, plus 6.25. It should add up to 17.5.
Oh, okay. Sounds good. Thank you.
Yeah, okay, I'm doing it again. I'm doing it again, and if anyone wants to check my work, please go for it. Okay, and then another 6.25. I got 17.5 again. Okay, so what you do is you add up all of these numbers right here. Those are our squared deviations. Okay, these are what we could call our deviations because they are deviating from the mean, right? They're deviating from the mean. I don't know how to say that any differently. And these are our squared deviations. Okay. I'm saying that because, Natalia, I think those are some of the questions in the quiz, right? I think like sum of squares or squared deviations or something.
No,
Or no?
no.
Oh, there wasn't?
Very straightforward.
Okay.
It basically just tells you to solve for the standard deviation, and then
Oh,
it gives you like a list of numbers that you have to. From there, you find that the standard
okay.
deviation. So it's basically using what we used right now.
Okay. Okay, that's right. That's right. All right, then, then I know what I did. Or maybe it's in the test. so right there, know that those are deviations when we're taking away from this column right here, when we're subtracting the mean from our data points or our x's. Those are our deviations. And then when we square them, those are our squared deviations. Okay. All right. So moving on. We got 17.5 right here. Erase all this. We got 17.5 from adding up all of our squared deviations. Okay. And that number plugs in right here. So this big, long, complicated thing is a big old, sentence, or if you want to think of it that way, but really it's just this number right here. Okay, it's 17.5. Plugs in right there. I think it's called the square root. You have to excuse me. I call it the house. Okay, I call it the house. So there's a couple of rules about our house. No negativity inside the house. Okay, no negativity inside the house. If you add up a number and you have a negative right here, that is not going to work. Okay, we cannot have any negativity inside the house. Okay, so it's got to be a positive number, and that will be carrying forward. Okay, so we got 17.5. Now you do everything inside the house first. Okay, so what we're going to do is we've got to divide the 17.5 by 6. Okay, so I'm working it on my calculator real quick. 17.5 divided by 6, and I get 2.91666666 repeating. Okay, remember, I will always go to the second decimal. Okay, So I had 2.916. So I bumped that 1 to a 2. Okay, I bumped it up there. And that's where I got the 2.92. Okay. When and if we ever do anything where you all are free writing answers in, I would not mark it wrong if you put 2.91666. Even if you put 2.91, okay, that is fine. I would never mark that wrong, right? But I will round up to the second decimal right there, okay? Now comes the fun part where we have to take the square root, okay? I'll pull up our calculator here. Now this one is nice because it's right here, okay? It has a button for it. If you're using your phone, like I like to use, when I do it this way, I know y'all can't see that very well, it doesn't have the square root, it doesn't have the house on there. I have to turn it to the side. And then my calculator changes and it gives, or not, and then it gives me the square root button, okay? So play with your phone or your calculator and see how that works. The other thing is all calculators are kind of different right here. Sometimes you have to punch the number first and then the square root button. Some you have to hit the square root button first and then the 2.92. Okay, so in mine, I have to, on my phone, I have to hit the square root button first and 2.92 and then equals, and I get that 1.7088, blah, 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 blah. If you do it wrong on your calculator, it should tell you an error, okay? Let's see, this one, it looks like it's gonna let me do, oops, go back. 2 and then equals. Oh, it's not even working. It just doesn't do anything. Okay. So this one, sometimes it gives you, it says syntax error. Okay. If you get an error message, just go back and flip it. Do it the other way. Okay. So that one I tried to do the house first and then push 292 and it didn't work. So this one you have to do the number first and then the house and it'll give you the number. Okay, so just play with it a little bit. Right now, when I'm going over all this, it reminds me of a story. One of the first times I ever taught stats, and it was at Valle Verde, and I had a student that would come and go as he pleased, which to me is not a big deal. I don't care. He, well, I don't know, maybe he was going to work, maybe he had something important to do. I don't know. Sometimes he would come to class and sometimes he wouldn't, which again, I don't, whatever. But the problem with that is he also wasn't getting very good grades on his tests. And so finally, at the final, when he came, he did show up, and he got his test and he went and sat down and it was a long time. And then he comes over and he asks for a pencil. And so I just kind of, in my head, just kind of chuckled because he sat there for so long without the pencil. And so I was just kind of like, what was he doing that whole time? But anyways, that was going through my head. So now he got his pencil, and then the class goes on for, again, everybody's doing their test. And he comes up to me and he doesn't say anything. He just shows me his calculator, like gives it to me. He doesn't say anything to me. He just hands me his calculator. And so I take it and I look at it and it had the syntax error on it. Now he didn't ask for help. He didn't say, why is it doing this? He didn't say anything like that. He just handed it to me. And so I just hit clear and I gave it back to him. And that might have been one of the most kind of passive aggressive things I've ever done to a student. And I'm not necessarily proud of it. But had he been in class, all those 4 months, we could have worked through that issue, right? A long time ago. And you guys can see how early on we start working with square root, right? And so for it to already be the final, and for him not to know how to work his calculator, and just do this one part, what to me was very telling that you know, and he didn't pass. I don't know. But anyways, his name was Jerry. I don't know what's happening with Jerry now, but I hope he was just young and he didn't take it seriously, and now he's on the right track and he's doing what he's doing. But anyways, so now's the time to work through our calculator, to figure out anything like that we might need help with, okay? Because I'd rather us work through it now and not on the final, okay? The other thing that I wanted to bring up is, or I don't know, I already lost it. But anyways, do y'all, or I know you have questions, not problems. I know you have questions because we haven't gone through very much of it, but there's that. Let's move on to the next slide, and we can do another problem here. Oh, no, what I'm doing for you guys is showing you this other formula here, okay? So the formula we just did is what we call the deviation method. And it's called the deviation method because we sit there and we calculate each of those deviations. We take the mean and subtract it from every score. We find those deviations, okay? This one is called the raw score method, okay? The raw score method. Because if you see here, all we do is work with the raw scores and we square them, okay? The other formula is taught to people because it's like this naive idea that you're going to truly understand what you're doing and you're going to know where these numbers come from. And it's this, you know, just this sense of like, we know you get it, okay? The raw score method, if we just did this one, we're all scared that you guys aren't going to know what this means, okay? And, you know, it's okay. I'm okay with that. So this raw score method, now he looks a little bigger and he looks a little scarier, but it's a lot easier, okay? One, because you're not dealing with all of those decimals, all right? You're not gonna have any decimals here really until maybe towards the very end, but you're not doing all that subtracting, you're not doing all that, those decimals and rounding and things like that, which is where errors can happen, okay? So a lot of times we say that this method is a better grasp of the raw or the standard deviation because we're not having to deal with all those rounding issues. Now, on the previous example, we only had 0.25, right? But sometimes when you're doing the deviation method, you can have decimals that are really long. And it goes out to many places, and that's where we start to have rounding issues. Okay, so here, this one you're just dealing with whole numbers. We have the exact same raw scores here. All of our numbers are the same. Okay, and what we're going to do is we are going to take those raw scores. They're just repeated right here for you. Add it up. This is the sum of X. We're going to square them. And when we add this up, it's the sum of the X's squared. Kind of hard to say. So these are our sum of the X's squared. This one is our sum of X, okay? Now, I sat there and I colored that, but I'm going to do it different. So that one's going to be yellow, and this one, I'm going to make it, let's do a contrasting color. Let's do blue. I'm going to make this one blue, okay? because I want you to see where these numbers, this is the hardest part, guys. Or anyone confused about the squares or anything like that? No, it's okay. Okay. So these two numbers here, we have yellow and we have blue. Okay. So easiest way, the big number always goes first. Okay. Your squares are going to be your bigger number and it's always going to go first. It's this one right here, because this one is the sum of the x's squared. Okay, that one is the sum of the x's squared. And so the bigger number is going to go first because we can't have negativity inside the house. Okay. All right. Now, the yellow number is this one, the x. Our sum of x goes right here. Now, they look very similar, guys. And I know that. And I know that some people who have like math phobia and anxiety and stuff like that, just look at them though. It's like a puzzle piece. They're very similar, but they're not the same. The blue one is the sum of the x's squared. The yellow one is the sum of x squared. Very close, but different. The blue one is the sum of the x's squared. The yellow one is the sum of x squared. Okay, now if you're looking at it and you're saying, well, those numbers are the same, they're not. It's not the same number, okay? You're going to get a very different number, all right? So this is where 91 goes right there. The 21 squared goes right here. And our n is still the same. It's 6 because it's the same problem, okay? Now I want you to see, I want you to do, well, I'll do it on my calculator here so you guys can see it. Where'd my calculator go? Did I close it? Okay, I'm going to show you it's not the same. 21 squared is a big number, 441. Okay, so when you square the numbers and add them up compared to adding them up and squaring them, you don't get the same number. Okay, it's not the same thing. So 21 squared is 441. Okay, now I know that's a big number, but don't worry because right here we're going to divide it by 6, so it's going to get small. Okay, let's switch to this one because this is where it continues on. Okay, I'll pop back and forth. So I just need to, you know what, I'm going to get rid of, sorry guys, I'm going to get rid of you real quick. Okay, so on our calculator, if you do 21 squared, you get 441. Okay, so we've got to do all of this stuff first. Okay, again, something that I didn't, you know, one of the things that I carried forward from all those years of math was, what is it? The please excuse my dear Aunt Sally, right? Or my kids tell me PEMDAS. Well, PEMDAS and please excuse my dear Aunt Sally is all of this first, right? Parentheses, exponents. Okay, we've got to do all of this first. So 220 or 21 squared comes to 441. We're going to now divide it by 6. And we get 73.5, which is right here. How are we doing? Any questions right there on that step? I hate that that was 2 different slides, but are we okay with that? I can't see you, so I don't know if you're nodding your heads or not. Hopefully you are. If you have a question, please ask.
I have a question.
Yes.
The one we did before, which was the deviation method,
Uh-huh.
is that like just another way of solving for the same answer,
Yes.
like the raw method? So you can use
Yes.
either one?
You can, yes, you can use either one. And you're going to see, look, right here is where we pick up on the deviation method, right? Do those numbers look familiar? The 17.5. Yeah. So who is this?
Oscar.
Oscar. Hi, Oscar. You can do either one. Which one do you like better?
Well, so far the deviation method, but
Okay.
we'll
The
see.
only thing I'm going to say about the deviation method, it's fine, obviously, to do. When we move forward and our formulas start getting a little bit bigger, they're going to be some variation of this formula, if that makes sense. It does get more complicated than this, and those formulas are going to be like offshoots or variations of this one. And so right now for this test, you can do either, of course, but just kind of hang on to this one too, okay? Just a little bit. But so both of them, you know, the deviation method, there's just a lot of work up front. You know, there's the subtracting and then the squaring. This one, there's not a whole lot of work up front, but the process becomes longer. There's more steps in the formula. Okay, and so this is why we have some people that really like the deviation method, and then there's some people that just like this one a lot better. So whichever you choose, okay, is fine. You will get to eventually the same answer. Okay, so the 91 minus the 73.5, you're going to get this 17.5 right here. Okay. When we 17.5 divided by 6, we get the 2.92, and then we get the 171 for our standard deviation, just like we did with the deviation method. Okay.
Oh, okay. Yeah, well, I'll definitely like you said, you know, hang on to both so that way I'm prepared for like what's coming up the next two chapters.
Yeah, and I'm, you know, and I'm not trying to say that like to scare you or in any way or anything like that. It's just, yeah, the deviation method can get very long and involved, and it's a little, sometimes it's just a little easier to do it this way. But yeah, it's whichever one you like. Okay. That's a good question. Thank you. Thank you, Oscar, for that question.
Thank you.
Any questions? I know this was, it is a lot. It's a lot of information. But Natalia, you already did the quiz, and there is one where you have to find the standard deviation, right? And you were able to do it, obviously.
Yeah, I was able to do it. I didn't use this method, the raw method.
Uh-huh.
I used just the regular standard deviation method.
Okay.
I mean, but like you said, it essentially gives you the same answer.
Mhm.
But like the other one, I don't know why, but for some reason, like when I see formulas, I like to do it like step by step. I like to see the steps separately in order for me to make sense of it.
Yeah.
But like you said, I mean, I think as we get to more complex or bigger equations, it's good to learn like other bigger equations so you'll be familiar with the
Yeah.
other equations that are scarier, you would say.
Yeah. Yeah. You'll see in those other formulas, you'll see, oh, it's just asking for the sum of x squared here, or it's asking for this. And so there's just some familiarity within the formula from this one. And that's not to say that we can't do it in a deviation method, but it takes a long time, and it's a lot of work compared to this one, certainly when it gets more complicated. Okay, so I know I spent all this time on standard deviation and I didn't talk about variance. And the reason why is variance is super easy. All it is your standard deviation without the square root, okay, without the house. So we've already been doing the variance without even knowing we were doing the variance. And so I always tell everybody, you know, you don't even have to worry about it. It's just that number right there. So our variance in this example is 2.92. Okay, so I'll show you right here the formulas. They're the exact same formula. They just don't have the square root. They don't have the house. Okay. Now, if you're wondering why would you do one or the other, the reason we take the square root in standard deviation is we are undoing the squares that we did at the very beginning of the problem. Remember way back here, I said this would just be 0. And so we had to square them so we could get those absolute differences from the mean. When we square them, we make these numbers kind of big, okay? And then when we do the square root, it gets rid of the square because those are opposite each other. And so we get a number that's smaller, and it makes more sense with the data that we're looking at. So for example, if we go back to what in the world were we talking about? We were talking about number of classes. And we said that the mean number of classes was 3.5 for this data set. So we're saying on average, people are taking 3.5 classes with a standard deviation of 1.71. Now what that means is we have an average of 3.5 and people are deviating from that mean in chunks of 1.75. Some people are down here, 3.5 minus the 171, and some people, or most people, are up here, 3.5 plus the 171. So it's giving you a picture of how people are deviating from that mean on average. It's telling us we're at 3.5. Think of my head as 3.5. Some people are over here, 1.71, and some people are over here, 1.71, deviating from that mean. If that conceptually makes sense, if people like pictures maybe a little bit more. If we used variance, the variance was 2.92. That's a really big number for the mean of 3.5. That's like 3 classes above and 3 classes below. It just didn't really, it just doesn't make sense with the data, okay? And that's why we square them, and then we go back and bring that number back down again into what I like to call like a more bite-size number that makes sense with the data, the 1.71. People mostly use standard deviation because it just makes sense to people a little bit better. It's a smaller number, and it it's not conceptually difficult to think about. The 2.92, or when we use variance is a bigger number than standard deviation. And sometimes it's just hard for people to kind of understand it. And so, or they just look at it initially and they're like, well, that doesn't make sense. But we will use variance later, like in, you saw in your syllabus, ANOVA, which stands for analysis of variance. So we'll use variance then, but for the most part, most things, the news organizations, studies, they'll report the mean, and then they say the standard deviation, okay? Medical journals, I know I've gone over the hour, and I really apologize, and I'm gonna move it on, I promise. News organizations or medical articles or things like that, you'll see something. Sometimes it is the big M, okay, especially in medical. They might say, you know, the M is 3.5, and then they might say standard deviation plus or minus 171. You might see something like that in you see that a lot in the like polls, since we had the election not too long ago. They'll give you, you know, whatever the number was, and then they'll have a plus or minus 171, or, you know, something like that. Then they're telling you how is that deviating from what the poll is, or what the number, what the average is that they're telling you. I hope that makes sense, kind of. So on the quiz, you do have an example or a problem where you're working through standard deviation and variance, okay? Work on it. If you have any questions, please email me, message me, you know, and we can work through it. I'll have this class again, you know, tomorrow, but again, I talk about the same things. It'll be the same presentation, but if you just wanted to get in and go over it again, if you guys, if anyone is interested in like a Thursday evening, or Thursday afternoon kind of ask questions, kind of open study type of thing, please message me and let me know, okay, that you're interested in that, and we can set that up. If you guys want to do a little study session or ask questions or go over another example of these, okay? So any questions right now?
I don't have a question right now, but I do find that Thursday evenings would be like perfect for like I mean, pretty much anything like I guess tutoring kind of thing or study sessions.
Yeah.
Yeah, that would be good.
You would like that?
Yeah.
Okay. If that what?
Like I'm okay with it. I don't know if anyone else finds it a good time.
Okay. Yeah, it doesn't matter to me. Thursday, will you message or like email me or do it in a message or on the group chat thing, not on this chat, but on the Blackboard chat, and then maybe some people could chime in, or I could start it. If you want me to do that, I could start it and ask people like what would be a good time. What would be a good time for you?
For me, like Thursday afternoons is good, or anytime.
Anytime?
Like Fridays, well, for sure, not mornings. On Thursdays, like Thursdays, Fridays, afternoons.
Okay.
Even Sunday afternoons would be okay, but I'm sure a lot of people, I don't know if that's like their day